Thank you so much. So sorry I couldn't be there in person. I'm sure you're having a wonderful course so far. I saw the agenda and it looked fantastic. So all the best. Wish you the best successes. So why do you need artificial intelligence in all? Obviously, it's changing our world now with things like ChatGPT. We've been trying to apply artificial intelligence in interventional cardiology for many years. But this is sort of the way we've been assessing things so far. We've been using coronary angiography from the 70s, probably in the late 90s, early 2000s. We introduced IVIST in the early sort of to late 2010s. We started introducing OCT, and finally we've got AI-driven PCI guidance, which is actually clinically available and in practice. This is somewhat of what a normal pathway of iteration looks like. So when a new technology is accepted, really when it's proven to be beneficial and it's easy to use. So what happens is we, as operators, say, well, really, is it that much better than what I'm already doing? And then we develop an attitude towards whether we're going to use it or not. And then we start to determine an intention to use it and then actually use that system. So let's see, why do we need to do it? Because it has to be proven to be beneficial and it has to be easy to use. So let's talk about why we don't, or many don't use intravascular imaging. Well, there's lots of excuses. I get great results. I don't know how to use it. It's not in the guidelines. There are no data. It costs too much. There's too much radiation and contrast. All of these things impact it. But I think one of the things that artificial intelligence can impact is how long the procedure takes, that the results vary when you use it, and you don't know what to do with the results. So that's certainly something that artificial intelligence can impact. So as you all know, we spent a lot of time taking the data from Illumian 2 and 3 and bringing you very practical steps to integrate into your PCI on what actually matters in terms of proving benefit. And one is the morphology, pre-PCI, then the length of the lesion to make sure you don't land into lipid, or now data showing eccentric calcium, diameter, medial dissection, post-procedurally, that the stent isn't floating with apposition, and finally stent expansion. And so we simplified morphology for everybody. We spent a lot of time on this. We said very simply, if you can see the intima media and adventitial layers visualized in the entire circumference, either the artery is normal or fibrous, and there's no additional treatment necessary. If we found a signal change, whether it's in the lumen or in the wall, there's a pathology, and as a result, we would treat accordingly. If it's high attenuation, it's red thrombus or lipidic plaque. If it's low attenuation, it's white thrombus or calcified plaque. And then we, based on that, created a very practical morphology-guided lesion preparation strategy. If we had fibrotic or lipidic lesions, we could direct stent or use a compliant balloon. But in the setting of moderate to severe calcification, we realized that there was genuine benefit for advanced lesion modification. We actually created the rule of fives, where we determined which stents were most likely to be underexpanded. And we identified that lesions that have 0.5 millimeter of thickness, 50% of the arc, and 5 millimeters in length were much more likely to be underexpanded. And therefore, identifying these by intravascular imaging prompted us to use more advanced lesion preparation. We even created very simplistic approaches on what to do when your stent was underexpanded and how exactly to post-dilate. And we said that if you have the ability to measure the external elastic lamina, you should use that. And if you can't, you should use the lumen. The background behind this was, whenever you use the external elastic lamina, you don't increase your complication rate, but you get a larger stent and minimal stent area. And then we also said, how do you do the whole stent rather than this concept of POT or proximal optimization? Well, we need SOT, stent optimization. The distal is where you're more likely to get the minimal stent area, so we need to spend equal amounts of time optimizing both the proximal and the distal. So we thought that we simplified this. But one of the big issues was that when we actually tried to apply this in our clinical practice, for example, here on this pullback, what you realize is that life is not so simple, okay? So this pullback has varying different morphologies of calcium. It has varying different plaque morphologies that are not calcified. And so as a result, using our equipment and actually determining how to treat this lesion wasn't that easy. So when we roll into the artery and look for a normal segment, it's really not that easy. This vessel is badly diffusely diseased. There's the tightest lesion. So we want to be just outside of this area. And so we mark that as our distal reference. But what do we do proximally, right? So here we can use the lumen diameter, which is 2.97 and upsize. But proximally, we have a problem because we have multiple lesions across the entire area that are small. So how do we cover this whole lesion? Now do we come to the ostium? And the point of this was, as simple as we made MLD MAX, it just still wasn't simple enough. And so that's where Ultreon 2 comes in. Ultreon 2 was designed to take away a lot of the complicated features or steps that still required a lot of human interpretation. And the idea was a maximum of 2 pullbacks, one for pre and one for post, to really streamline this work. We do the same OCT setup as always, which takes less than 30 seconds, purging the catheter, draping the dock, and connecting the catheter. And then we do the 4 Ps, which is positioning the catheter distal to the lesion, clearing the artery, and doing our pullback. So this is what we were all familiar with. But now what Ultreon 2 did was really improve a lot of the things that were nuisances before. So for example, the angiography registration, which now goes proximal to distal, is significantly improved. It also allows us to modify the position of the lens so that it might be more easy to actually figure out what the co-registration is. And so we altered pre-PCI OCT and post-PCI OCT from MLD MAX to AI-driven MLD MAX. So let's see how that actually impacted us. So Ultreon relies on 4 steps which are focused on these areas: morphology, which is the M, sizing, which is the length and the diameter, the deployment, and then finally the review, which is the max component of Ultreon. And so for morphology, where we want to determine whether something is 0.5 millimeter thick, 0.5 millimeters, 50% of the arc, or 0.5 millimeters long, all of this is automated in the morphology segment. And we know that we start to pick up severe calcification on OCT, on angiography, when it gets to about 101 degrees, 4 millimeters, and 0.5 millimeter of thickness. We can identify, normally what we would do is identify calcium by trying to look at the longitudinal and looking at these fine details. But of course, determining whether this is lipidic plaque or calcific plaque is very, very difficult. So to apply MLD MAX and apply the rule of 5s, it's much easier to use Ultreon because there's automatic detection of the calcium, which is present in orange. There's automatic detection on the longitudinal, which doesn't require us to analyze the subtleties between lipid and calcification. It shows us the calcium arc, it shows us the calcium thickness, and the calcium profiles. And here we can see on the pullback that we're able to see all of the different plaque morphologies, but also determine how diffusely diseased this vessel is with calcification. And for example, if you're going to be using orbital atherectomy, you need to know exactly where you're going to be able to treat. And if you're going to be using intravascular lithotripsy, where are you going to be focusing your pulses? And so you can see, and we've automatically identified all of the areas that meet the rule of 5s in this situation. So why do we need to assess the lesion morphology? Is because they have different strategies for treatment, as we mentioned before. These areas are the ones that need more advanced lesion preparation. Of course, we can do length and diameter in 2 ways, which is the automated version, which is shown here, which identifies the external elastic lamina automatically at the distal and proximal reference, and therefore gives us EL-guided PCI rather than using lumen or using a guesstimate. Here you can see the proximal reference, here you can see the distal reference, we see that the distance is 23 millimeters, and so as a result, we know exactly what length of stent that we need. We also search for healthy landing zones because not all landing zones are equal. For example, this area is excellent because there's 360 degrees of external elastic lamina, and here there's 360 degrees of external elastic lamina. The more external elastic lamina you have, the less likely you are for post-procedural edge complications. And we want to avoid this situation of landing our lesion or stent edge into TICFA or into calcified plaque. So what about diameter? We want to know whether the EL can be identified. If the EL is identified, we round down to the nearest stent size. If we can't, we use the lumen and we upsize, and all of that happens automatically. Now finally, this is also critical. The co-registration feature of the OCT not only co-registers the angio, but also co-registers the rule of fives. So here you can see a densely segment of calcium, which can be modified by focusing your IVL balloon, for example, in exactly this area on the angio. So you know exactly where your treatment zone is. This is a major feature in Ultreon 2.0. When you've identified your lesion and you keep this on your boom, you can actually have these right next to each other and minimize your risk of geographic miss. So once we've done our early user interface, we go to the MAX procedure. And for the MAX procedure, as you know, we're looking for medial dissections. And when their arc is greater than 90 degrees, now whether it's proximal or distal, we actually learn that we should be treating these. When the stent is malopposed, particularly when it's floating at the proximal or distal edge, additional balloon dilation with a semi-compliant balloon is valuable. And when we're underexpanded, we should focus on the area of underexpansion. And this is a great example of a proximal left anterior descending, where after PCI, we still have underexpansion in the distal segment, which can easily be modified. We're able to actually go ahead and compare pullbacks. And you can see in this example where we start off showing our minimal lumen area, which is 1.91, and after treatment, we identify a stent expansion of 100% with a minimal stent area of 9.52. So going back to our first case, how does this actually help? And it not only helps with reducing operator error, but it also improves time. Morphology in our first case took 30 seconds by AptiView, 30 seconds for length, 45 seconds for diameter, which was about 2 minutes. And we can do all of that by Ultreon in just 25 seconds because everything is brought to you. So these are some of the key things that I think make the MLD MAX much more integrated and beneficial for using artificial intelligence in our clinical programs.